We're going to take our next activity, 1.3, step by step. It's probably got the most parts to it of all of the ones. So we're going to determine the MMC and LMC. Remember, that was maximum material condition and least material condition. And we're going to look at those fit requirements that we saw over here from our load bearing. And we're going to use the IPT files that we were given. We were given the design files. And we're going to compare the numbers that we've gotten, what the engineer says they want. We're going to make a little table to tell us how things are going. Once we've got everything all written down, we'll be ready to go on to the next activity. So we're not making a decision yet. We're just getting numbers. And we're going to put them into a table. So let's take a look at what these engineering notes look like. They're a Jamboard. Very typical of what design review notes might look like. There was somebody who had a drawing, and through the review process and some thoughts and going back and forth, the engineer has come up with the fact that the outside of the gear will run on the inside of the housing, and the minimum gap per side, when they're centered up, the minimum gap on each side will be 0.005, 5/1000 of an inch, and the maximum gap will be 0.020. Now, we don't know why they came up with that. It could be because of some lubrication, or just the ability to move around a little bit is good. Or maybe it was manufacturing tolerances or something they could do. But that's what he came up with. The gap right here. No matter what, any gear I put into any housing, regardless of its size, so long as it's within print, in its tolerance zone, will give me a gap of between 0.005 and 0.020. And so you can see that right here. This little gap right here is going to be between 0.005 and 0.020. That's the review of the engineer's design review notes.